Hi, and thanks for watching another instructional video for CSCI 1300. In this video, we will cover how to implement pseudocode to solve a problem, then build that pseudocode and test and debug it, and make sure that we're getting the correct and desired output from our terminal. So, I have a blank main here, and I have a template set up for a problem involving evaluating a Richter scale for earthquake damage. And the Richter scale is something that goes from 0 up past 8, and these are usually decimal numbers. So this is all information that we can take into account when developing our pseudocode. So the first thing that we should do is we should probably ask the user for some input on the range of values that could be listed on the Richter scale. The next thing I would probably do is I would test for invalid input from the user to make sure that it is within the correct Richter scale range and that we're not getting something that's not a number. The next thing I'm going to do is I'm going to evaluate the input and figure out how much damage would be caused based on that on the scale. The next thing that we can do is we can output the damage of the earthquake back to the user to tell them how bad it will be. As far as tests go, we can probably predict what kind of tests we need to make on the input. So we're going to have to validate the input of the user so that we're using the correct information. So the first thing I would do is I would make sure that there isn't a word or a string being input because we need decimal numbers. And I will also do an evaluation for anything outside of the range of the Richter scale. There have been earthquakes larger than 8.0 on the Richter scale, such as in Alaska in the 60s. So that means that we don't really have a high-end range for the Richter scale, but we do have a low-end range, so we can't have negative numbers. So we do need to check for that when developing the code. So the first thing I'm going to do is I'm going to create a number. That number should probably be some kind of a double or some kind of a floating point number. I'm going to use a double. And I'm going to ask the user for that information. So I've declared a number called num, which will represent our Richter scale number. And then I'm going to ask for that number from the user. So I'm using a cin to grab that. So the next thing I want to do is I want to build some edge cases for validating input. So the first thing I want to do is I want to check that I have not received a word and that I have a number. And I can do that through the cin.fail, which we have covered in a previous video. So I'm going to drop in an if statement checking for whether or not I actually received the correct input into num. And if so, then we can continue. And if not, then we're just going to stop the program and ask the user to start over. So the next thing I'm going to do is I'm going to do an additional check to see if the number is out of our range. So we know that it has to be negative for it to be out of the range. So I'm only going to check for non-negative or non-positive numbers. So if we get a negative number, then we will stop the program and prompt a similar message. So at this point, we should probably have covered all of our edge case checks. So once we reach this comment line, we should have passed all of our edge case checks and we should have validated the user input, which means that we can now do some kind of an evaluation on the number that we have from this point forward in the code. So the first thing I want to do is I want to think about working from, I guess, the high range to the low range. So I'll think about any numbers larger than 8. If anything larger than 8 appears, then there is going to be serious damage to every structure in the area. The next thing I want to do is I want to use in this logic, there can only be one output. So I can't use a series of ifs because that might cause multiple things to get printed. So I'm going to have to make this conditional on the first if statement. So I'm going to use an else and use if-else-if logic for the ranges of values that could potentially be there between the bottom of the Richter scale and the top of the Richter scale. And at 7 or larger, between 7 and 8, there could be some buildings that will get destroyed, but maybe not all of them. And if we do the same logic for a 6 to 7 range, we see that we can get some building damage, some may collapse. And then we want to handle anything larger than 4.5, which is where damage really starts to occur in the Richter scale. So we're saying anything larger than or equal to 4.5 but less than 6 will have damage but probably won't destroy large sturdy buildings. And the last thing I want to do is I want to cover the bottom of the range. So I want to cover anything below 4.5 that is still positive. So if it's a 0 to a 4.5, then I'm going to use the else to catch the remainder. So that would mean that there's no destruction for the buildings, it's a minor earthquake. So now I'm going to double check my code, and I'm going to look through it, save my code, and check for any errors. If, for instance, I get an error and I forget something along the way I'm going to solve that is by compiling it and realizing that I will get error messages in the terminal. You should go to the first numbered line. This is coming from line 42. So I realize here that VS Code is telling us there should be some kind of a semicolon right after the inline. So we're going to have to fix that, save it again, and recompile. At this point, we're no longer getting any compilation errors. So let's go ahead and run the program and test some things. The first thing I want to test is a word, some kind of input value that's not correct. So let's try the word Richter. We can see that we're getting the correct cout, which means that this logic was true, and we stop the program, so that's good. The next thing I want to do is I want to try a number that is negative. And that's good too, because we are solving that problem as well with our second edge case check. All right, so now let's try a number that is larger than 8. That's good. We're hitting the top of the range, so anything larger than 8 will be evaluated. Let's go ahead and check for the mid-range and the low range as well. So let's try a small number, something less than 4.5, no destruction of the buildings. Okay, that's good. That means we're meeting our low end. What about if it is 6.5? That means many buildings damaged, and we're getting that. So it looks like everything that we have written not only is syntactically correct at this point, but we have identified our test cases and implemented ways to test those based on what we have excluded from the input range that we want from the user. That's all for now. Thanks, and happy coding.